Section 7.1, radicals. Radical looks like this. This is the sign we use for radicals. The number under the radical is called radicand. That's radicand. The number over here inside the V shape is called index. And that number can be either 2 or 3 or 4 or 5 or 6. So it's whole numbers greater than or equal to 2. I call radicals anti-exponents. So later on, when we deal with exponents, radicals undo the exponents. So basically, this is what radical does. Let's say you have been asked to simplify so-called square root of 25. Remember, if the index is 2, okay, sometimes by default, they don't even show the 2. So the way you read this, you would read it as square root of 25. If they have any number in any other index in mind besides 2, they have to show it. In other words, this right here reads cube root of 8. And then if the index exceeds 3, like let's say, oh, I don't know, let's say this guy, then you would go by the index. You kind of read this as fourth root of 11. So that's how you read radicals. So if the radical doesn't have an index, by default, it means there is a 2 there you don't see. So what's up with the 2? Well, suppose they say simplify square root of 25. That means give me a number, just one number. If I multiply that number by itself twice, I get 25. Remember, this is the same number. I'm just multiplying by itself twice. Why did I multiply it by itself twice? Because the index is 2, correct? So the answer for a square root of 25 is 5, and you drop the radical sign. Do you see it? This guy reads cube root of 8. You know what that means. Give me a number. If I multiply it by itself 3 times, because the index is 3, I should get 8. Well, that magic number you and I, we both know, it's 2, because 2 times itself 3 times, 2 times 2 times 2 gives you 8. Sometimes you have a fraction under the radical. You can split this and write it as a ratio of 2 radicals. Square root of 49 is 7. The square root of 81 is 9. So sometimes you get a fraction. Sometimes the number under the radical is decimal. But how do you read this? You read this as 100ths. So that's like 1 over 100, which is the same as the square root of 1 over square root of 10. So the answer is 110, which is 0.1. Now, how do I check these answers? Well, depends what the index is. In this case, index is 2. You just don't see it. So if you square this, you should get 0.01. If you raise 7 over 9 to the power of 2, you should get 49 over 81. If you raise this 2 to the power of 3, you should get 8. If you raise 5 to the power of 2, you should get 25. That's how you check. Sometimes we have negative under the radical. If the index is an odd number like 3, 5, 7, it's okay to have a negative under the radical. Why? Because remember, this says give me a number, which I multiplied by itself 3 times, I get negative 27. And you and I, we both know the answer is negative 3. However, if the index is even, and you have a negative number under the radical, we don't have an answer. As a matter of fact, we do, but this is not a real number. At the end of this chapter, we'll be talking about kind of numbers called imaginary numbers, okay, and or complex numbers. So what we mean by not a real number, that means there is no picture of this number on a number line. So remember, if n is even, then what? Then nth root of x is not a real number. In other words, if this guy, if x is less than 0. So keep that in mind, please. Okay, sometimes the numbers are not round, so you just have to use your scientific calculator. Approximate the answers to the nearest hundreds. That means what? 2 decimal places. Turn on your scientific calculator, go like a square root of 59. So the answer is approximately 7.68. Notice it says round your answer to 2 decimal places. What about this guy? Well, that would be what? A negative. So this negative goes for the right. What is cube root of negative 53? Remember, 3 is odd, so it's okay to have a negative under the radical. So for this, on my calculator, I don't know about yours, I have to push 3, and then this key right here to see this, radical with index, what, x, and then I will, what, push negative, and there it is, negative 53. So I get negative, what? Oh, 3.76. But negative times negative gives you positive 3.76. Notice I kind of drew a line here. 6 is greater than 5, so I dropped 63. I added 1 to the 5. That's called the rounding of the decimals. So that's why the answer is 3.76. Don't forget this minus multiplies the minus you get out of the cube root of negative 53. So the final answer is positive. We have a negative number and the index is even. So for now, we just say not a real number. Remember, this is going to be a complex number. So that's called complex number. And we're going to go over this at the very end section of chapter 7. How about cube root of 15.625? Oh, well, so let's see now. So on my calculator, I have to push 3 because it's cube root. Then this notation. So right now this reads cube root. I'm ready to type 15.625. And the answer is 2.50, round to the 2 decimal numbers. So I just draw the line here. 0 is less than 5, so I keep the 0. The principle of square root, which is also known as positive square root, and that's like if what? If you take in the square root of a square of a number, the answer always has to come up positive. So this reads absolute value of x. Okay, what does that mean? That means if you, take the square root of negative 3 squared, the answer is not negative 3. The answer is absolute value of negative 3, which is positive 3. Why is that? Because first you have to square this guy, get what? 9. And the square root of 9, you and I, we both know it's 3. It's not negative 3, correct? What would be the square root of negative 1.19 squared? It ain't negative, it's positive because it has to be absolute value. What about the square root of 119 squared is 119? What about the square root of x minus 3 squared? It's not x minus 3, is absolute value of x minus 3. Okay, what about the square root of x plus 8 squared? It's not x plus 8, is absolute value of x plus 8. And finally, square root of 3x squared minus 1 squared is absolute value of 3x squared minus 1. So that pretty much covers that section. I will see you in the next section. Thank you.